All right, today we're going to be talking about our polygons. So, a polygon, it's a two-dimensional closed shape with three or more line segments or sides. Each segment intersects at exactly two others, but only at their endpoints. So, here's some examples of polygons. So, closed, close, those are all good. They have three or more line segments, and it intersects with exactly two others. All right, these are not polygons. So if you notice right here, it's opened. Here it's also opened, and these are not straight lines. It's curved, and so it's not all line segments. And then here it's crossing and it's open. So those are important things to know when you're doing this. So now let's classify some polygons. So convex, it does not cave in on itself, and angles are less than 180. So each angle is going to be less than 180 degrees. Then you have concave. If something caves in, like right there, it goes in. So it caves in on itself, and at least one angle is greater than 180. So if you look there, that's pretty big angle. There. If you look there, that's a pretty big angle, so it's 180, or it's greater than 180 degrees. Regular just means it's convex, so it doesn't cave in at all, with congruent sides and angles. So all the angles are congruent and all the sides are congruent. And then irregular just means sides and angles are not all congruent, can be concave or convex. It doesn't matter as long as it's a polygon. So let's look at some of these examples and then say if it's a concave or convex. So in this first one, no, this is not, because there's more than two endpoints because of how the line through the middle goes. All right, and then this one, yes. So you've got your angles, it's all closed, it doesn't have anything intersecting. And this is convex. So convex because none of the angles go in. So it would be this example right here. All right, so let's look here at concave. Right here is where it is concave because it goes in. So this, because of here, it's concave, but it is a polygon. So I want you to try those two and determine if it's a polygon, and if it is, say if it's convex or concave. All right, so now let's go ahead, let's do this table. Now what I want you to do on the very bottom is extend yours, because it actually went to the other side and that doesn't help us. So we want the table all on the same side. So I just extended my table. All right, so now diagonals have been drawn from one vertex in each polygon to the non-consecutive vertices. Use triangles created to find the interior and exterior angles of the polygon. So I started to fill out the table, and we're going to start noticing some patterns happening. So here, three sides, and the number of triangles is just one triangle. The sum of the interior angles is 180 degrees. So now if we want to find one angle, and we know it's a regular polygon, meaning all your sides are the same, all the angles are the same, I can go 180 divided by 3, and that's going to give each angle is going to be 60 degrees. So if we were to do the sum of the exterior angles, that would be 360 degrees. And the measure of one exterior angle would be 120 degrees. So you're going to take the sum divided by 3 since we have three sides. All right, oops. All right, next up, we have another regular polygon. So remember, all your sides are the same and all the angles are going to be the same. So we have four sides, but we split it so there's two triangles. So to find the sum of the interior, you take 2 times 180 and that gives you 360 since we have two triangles. And then the measure of one interior angle, well, if we have 360 divided by 4, that's going to give you 90. Sum of the exterior angles is 360, and I'll give you a hint, all of these are going to be 360. And then to figure out one exterior, you just take 360 divided by the sides, and that's going to give you 90. All right, so if you're to do this correctly, you should have 5 sides, but 3 triangles. So you're going to take 3 times 180, and then that's going to give you 540. So that's the total for the angles. But if you want to find one, you have to go 540 divided by 5. And that's going to give you 108. All right, this is 360. Like I said, all of these are 360. And then to find your one exterior angle, you're going to go 360 divided by 5. And that's going to give you 72. All right, I want you to try 6. Fill that out. And then we can start to apply this rule to any polygon. And so here, you could just write N gone, so any kind of polygon. And for sides, the side, we're going to put N, for that's unknown at the time, and we can substitute any number in there for the sides. The number of triangles, so you're going to take however many sides minus 2, because every time you connect something, you're taking away one of the sides. So now we're going to go N minus 2 times 180, just like we did over here. And to figure out the measure of one interior angle, where we're going to take N minus 2 times 180, but then we're going to divide by the number of sides. And like I said, everything here should be 360. And the rule is here, just what we did here, is 360 divided by 4. Well, here is 360 divided by N. And the reason why is because this one and this one make up a linear pair, which is 180 degrees. All right, so go ahead and make sure you finish the table. Get that all in, and then let's do a couple examples together. So here it says to find the sum of the interior angles of an 11gon. So you're going to follow the rules that we had before, where you take 11 minus 2. So instead of N minus 2, we're substituting in 11 times 180 because it's a linear pair. And then that gives you 9 times 180, and that's going to be 1,620 degrees. So that's the sum of the interior angles. Now, if we want to find the measure of an exterior angle, remember the exterior angles are always going to be 360, and if it's an octagon, that's 8 sides. So you just go 360 divided by 8, and that's 45 degrees. All right, now I'm going to give you a hint. This one you're kind of working backwards because you're finding the number of sides. So think about the information with a regular polygon that has an exterior angle for 72. So remember, it's always 360, but here we can either go 360 divided by x equals 72, but that would not be it. So you want to think about it because it's going to be 300. Oops, let me write this, sorry. So then when you divide that out, right, so we're just putting this here because it's going to be out of 360, and that's going to give us 5 sides. So you're kind of just working backwards. You're just plugging in the information from before, but here we're figuring out how many sides instead. All right, so let's go ahead and find that one, and then let's look at this example. So for this example, find x. If you notice, 1, 2, 3, 4. So it has 4 sides. So we're going to substitute it in for n. So 4 minus 2 times 180 is going to give you 360. So this plus this plus this plus this are all going to equal 360. And then when you solve that, x is going to equal 100. So that was pretty easy, pretty straightforward. And here for finding x, you want to think about the inside shape, and then you do have some exterior angles at the moment. But really, if we're finding x, you only need to worry about what's inside. But you do need to make sure you use the 42 to find that one, and you use the 80 to find that one. All right, so a couple different steps on that one. And then for 7, find A and B. Well, since we're looking here for A, that's the exterior. Well, remember the exterior total is going to be 360. So we're looking at all the exterior angles of the shape. We're adding them all together to equal 360. When you solve that, you get A equals 40. And now that we know this is 40, and I know it might not look like a straight line, this is supposed to be a straight line here. Now we know it's 40, now we can take this plus this and equal it to 180. So B equals 140. All right, so what I want you to do is I want you to go ahead and I want you to try that one. And then that, is polygons, and then your rules for polygons. So make sure you understand these, and then how to get the measure of exterior angles and the sides.